Hello, today we're going to be talking about the kinetic theory of matter. And to do that, I've got a screen that I'd like to share with you really quick. And go through this with you really fast. Here we go. So, the kinetic theory of matter. This neat row of cola bottles represents matter in 3 different states: solid, liquid, and gas. I know we've talked about this. The bottles and caps, of course, are solid. The drink inside is liquid, and the carbon dioxide dissolved in the cola is a gas. It's what gives the cola its fizz. Solids, liquids, and gases, such as these, have different properties. Solids have a fixed shape and a fixed volume. Liquids also have a fixed volume, but they can change their shape. Gases have neither a fixed shape nor a fixed volume. What explains these differences in states of matter? Well, to be honest, the answer has a lot to do with energy. Energy is the ability to cause changes in matter. For example, your body uses chemical energy when you lift your arm or take a step. In both cases, energy is used to move matter, and that matter happens to be you. Any matter that is moving has energy, just because it's moving. The energy of moving matter is called kinetic energy. Scientists think that the particles of all matter are in constant motion. In other words, the particles of matter have kinetic energy. The theory that all matter consists of consistently moving particles is called the kinetic theory of matter. So the differences in kinetic energy explain why matter exists in different states. Particles are attracted to each other, so they tend to pull together. Wait, those aren't the states that I'm talking about. Who's been playing with my presentation? There we go. Okay. So they exist in different states. Particles of matter are attracted to each other, so they tend to pull together. Particles can move apart only if they have enough kinetic energy to overcome this force of attraction. It's like a tug-of-war between opposing sides, with the force of attraction between particles on one side and the kinetic energy of individual particles on the other side. The outcome of this war determines the state of matter. If particles do not have, enough kinetic energy to overcome the force of attraction between them, matter exists as a solid. The particles are packed closely together and held rigidly in place. All they can do is vibrate. This explains why solids have a fixed volume and a fixed shape. If particles have enough kinetic energy to partially overcome the force of attraction between them, the matter exists as a liquid. The particles can slide past one another, but not pull apart completely. This explains why liquids can change shape, but have a fixed volume. If particles have enough kinetic energy to completely overcome the force of attraction between them, matter exists as a gas. The particles can then pull apart and spread out. This explains why gases have neither fixed volume nor a fixed shape. If they have even more energy, the matter becomes a plasma. And if the energy is so low that it no longer exists as a solid, we find the Bose-Einstein condensate. There are more than these 5 states of matter. Many of these states are subdivided or are found in extreme situations of pressure or temperature. We'll talk about those later on. So right now, what I'd like you to do, I'd like you to look at this, and it sums up the 3 main states that we find here on Earth, and the relationship between kinetic energy and state of matter. So as kinetic energy increases, the distance between particles increase, which can be seen graphically as the solids, liquids, and gas particles move further and further away with the increase in kinetic energy. So here's a thought question for you. How could you use a can of cola to demonstrate these relationships between kinetic energy and state of matter? Well, I suppose you could shake up the can of cola and then open it. Shaking causes carbon dioxide to come out of the cola solution and change into a gas. The gas fizzes out of the can and spreads into the surrounding air, showing that its particles have enough kinetic energy to spread apart. Then you could tilt the open can and pour out a small amount of the cola on a table, where it will form a puddle. This shows that particles of liquid have enough kinetic energy to slide over each other, but not enough to pull completely apart. Now, if you do nothing to the solid aluminum exterior of the cola can, it will remain the same size and shape. Its particles do not have enough energy to move apart or even to slide over each other. All right, we're going to take just a moment and view a video clip. Following the video clip, I have a couple of questions for you to think about. So please pay close attention, and we will be right back after the video. Okay, that was fun. So here's a couple of thought questions for you. Describe the motion of particles in ice, liquid water, and water vapor. Describe the motion of particles in ice, liquid water, and water vapor. Now, hopefully with your experience, you'll be able to provide a more scientific answer than what we heard the person on the street answering. Describe the motion of particles in ice, liquid water, and water vapor. Second thought question. Apply the kinetic theory of matter to explain the differences in your answer to number 1. So the answer that you gave for question number 1, you're going to apply the kinetic theory of matter to explain the differences in your answer. Take the kinetic theory of matter and use it to explain why ice, liquid water, and water vapor move differently. Okay, let's summarize. According to the kinetic theory, particles of matter are in constant motion. The energy of motion is called kinetic energy. So even a solid is in motion. It's vibrating. It's being held together in a solid form, but there is still some vibration going on. The energy of motion is called kinetic energy. And particles of solids have the least kinetic energy, and particles of gases have the most between solids, liquids, and gas. What has more kinetic energy than a gas? Do you remember? Well, hopefully you said plasma. And what has less kinetic energy than a solid? This one might be a little bit harder to remember because we don't talk very much about it. It's the Bose-Einstein particles. Okay, well, thank you for being here and sharing with me on the kinetic theory of matter. And I hope that you enjoyed it. I hope that you learned something new. And we'll be talking more about matter over the week. So look for those assignments and those activities and questions, and we'll see you later. Have a great day, stay healthy, and stay happy.